An index fossil that is important to the outcrop are Foraminifera. These protist microorganisms don't belong in the plant, animal, or fungi group. However, they are heavily abundant in soil, freshwater, and marine environments. Foraminifera can give us information on the relative age of marine rocks, and in this case, the limestone of the Glen Rose Formation, the ancient environment where the material that makes up the rocks were deposited, and the conditions of the water the foraminifera grew based off of the chemistry of their shell. The shell, also known as the test, is what sets the foraminifera apart from many single cell organisms because it's uncommon for these kind of organisms. These tests are hollow chambers with different levels of complexity and shape, some being single layered and some being multi-layered, that are made up of minerals that use calcium like calcite or aragonite. Some foraminifera build their tests by gluing together small particles they find in their direct environment. The picture below shows the test of three main classes of multi-chambered foraminifera. Miliolids and Orbitolina are two kinds of foraminifera found in the outcrop in front of you. And just like the outcrop, these two foraminifera were prevalent in the early Cretaceous during the Albian period, about 110 million years ago. These two foraminifera both are from the Cremistic kingdom, and organisms in this kingdom had rigid skeletons made of calcium carbonate. While these two foraminifera are from the same kingdom, they come from different classes and have completely different test structures. Orbitolina have conical or domal shapes with agglutinated walls of minerals like dolomite and calcite. Miliolids are disc-shaped and are also agglutinated in nature, with the chambers being filled with mud after the death of the organism. These two foraminifera in the outcrop belong to the Globothalamea and Tubothalamea class. The miliolid foraminifera belongs to the Tubothalamea class because of its disc shape, and the Orbitolina belongs to the Globothalamea class because of its globular chambers. While the classes are different and are useful for telling foraminifera apart, they share a distinct rDNA characteristic of being the only two classes with multi-chambered agglutinated foraminifera. The picture on the right is from a thin section, and a thin section is a thin slice of rock glued onto a microscope slide from the Government Canyon outcrop that highlights an example of a miliolid in the center of the square. The blue outlining of the shell is the epoxy, which is a synthetic resin that coats the thin section. Most of the shell is filled with mud, suggesting that it's dissolved and left a tiny bug behind. The picture on the left is a thin section of the same rock layers, but from Bernie, north of San Antonio. This microphotograph shows an example of two orbitolinas, one being the long horizontal microorganism in the center, and the other one right above it on the right, which are indicated in the red circles. The orbitolina on the upper right is actually the same as the large one in the center. The only difference is that it has been cut off and placed vertically, which allows us to see easily the outline of its many chambers. The center orbitolina displays the agglutinated quartz grains that these foraminiferas compile to give structure to their walls. Thanks to the identification of these foraminiferas in rock samples, the Glen Rose Formation dates back to the Albian stage of the Cretaceous, about 110 million years ago, and these same fossils are found in other localities in Texas, Arizona, and New Mexico.